Alright, so it's time for us to look at Android platform architecture. Now, I do realize that this topic may be a little bit daunting at first, especially if you're new to Android and you may ask yourself, why am I even bothering to look at this? This is too much. But bear with me here. If you're a little bit more curious and you want to understand the overall of what Android is, just keep watching this. Alright, so first of all, we need to understand what exactly is Android, right? So Android is not just one thing. That is the beauty here. Android is actually a stack of different technologies, of different libraries and so forth, as we will see soon. So if you think of it, Android is also open source. Now, this is a very important term used in software world. If you say open source, what it means is that anyone can come and customize it. You can take it, do your own thing, change it, and post it for other people to use, or for you to create your own Android operating system if you wish. Now, this is very important also because it allows Android to get better and better with time. Because if something is open source, that means everybody can actually contribute in the source code to make the platform even stronger. But for Android, there's also, I would call, the downside to it. The downside to open source, in this case for Android at least, is that anybody can take the Android operating system, the core libraries, right, the code that runs on Android devices, and they can take it and customize it to their liking. That is the reason why Android is all over the world. Android is used in a lot of different kind of devices, different sizes, different manufacturers, and so forth, because it is indeed open source. Now, that is a downside in a sense that for us developers, we most of the times have to deal with the fragmentation of Android. So whenever you use or hear this word fragmentation of Android, that's what it means. It means there's different manufacturers with different specifications in terms of the size of the devices that run Android. And so it's hard for developers to make sure that everything works on all devices that are out there. Now, let's talk about the Android platform architecture itself. So this will allow us to have a bird's eye overview, if you will, of what is the internal architecture of the Android platform. So to understand this, we need to look at this diagram here that you can find in the Android website at Google, okay? So very importantly here, you can see there's different layers. And now this hierarchy here is very important and intuitive for one reason. As we go up, things get lesser and lesser closer to the middle, meaning things are not as native as they are. So as you look at the bottom here, we have what we call the Linux kernel, which has all of the drivers that run Android. So this is the deep down of the operating system of the Android phone or a device that runs Android operating system. Now, this level here, we're dealing with power management, the batteries, how the batteries is charged and so forth, how the battery allows the phone to turn on and do all sort of things. So these are the very, very basics, okay? And within there, we have the audio, we have Bluetooth, we have USB, Wi-Fi, camera, and so many other drivers that allow the whole operating system to actually work. And then we go a level up, so less abstract, but still very abstract, called hardware abstraction layer. So this abstraction here communicates with what we have down there, those drivers in our Linux, so that there is another layer before we go to the top other layers, if that makes sense. So this hardware abstraction layer allows audio, Bluetooth, camera, sensors, and you notice all of those names are also included at the Linux level here. But now it's a different top abstraction layer that you can connect to it, that it's easier to interact with as opposed to the actual kernel, if you will. And on top of that, we have what we call the native libraries as well as the Android runtime. Those are two levels that are very important because now manufacturers or anybody who has expertise, they can actually tap into the native libraries to do certain things. For instance, if your application needs a little bit more memory or you want to manage the application overall memory, you could do that using the native libraries. And also interacting with the Android runtime. So what is this Android runtime? Well, the Android runtime is the focus library that connects the runtime of the entire Android system. So you can see if you are writing an application that's heavy on memory or you want to interfere with some of the Android runtime core libraries, you can do so using that level through C++ or C, right? And on top of that, we have the Java API framework. What does API stand for? Well, API stands for Application Programming Interface. Now that means that us, the developers, were able to connect, we're able to interface with the Android realm, with everything that we just talked about below that. Because now we don't have to go down to the Linux kernel, go to the drivers to do things. Nor do we have to go to the hardware layout abstraction there. Nor do we have to go to the CC+ libraries and Android runtime. No, everything is taken care of for us. All we need to do now is to access everything in this platform architecture here through our API framework. So you can see there is resource. We talked about resource there, and there's activity, which we talked a little bit about previously. So essentially activity is the Android view, is what users see on the screen. The single window, the single page that Android shows, it is indeed an activity. Okay, there's location, package, notification, window, and so many others. Okay, and you can see also we have the view system there. So like I said before, everything that shows up on the screen is part of the view system. Okay, and view system has a lot of classes, a lot of objects that we can actually use so that we can customize and create our applications. So us as developers, that is indeed where we're going to be leveraging all of our time, really, because that is the interface, the way in which we can connect and create things using the Android platform. And right above that, we have the system apps. What is this? Well, when you buy an Android device, there are apps that comes with the manufacturer, right? So every time you go and get a new phone, before you download any applications of your own, right? There are dialer, for instance, that is something that came with the manufacturer. And notice, because it's open source, a manufacturer can actually change the way the dialer looks, because they have access to all of this code that we're talking about here. So they can actually customize the dialer or email, calendar, camera, whatever else that comes with that manufactured Android system. Okay, so the system apps is what users will get the moment they buy the phone for the first time, okay? That is the reason why whenever you go in the United States, at least, whenever you go to buy certain kind of Android phone, there are so many of them out there, of course, and each phone usually, depending on the manufacturer and sometimes depending on the network provider, they will have different apps or different looks or different something different than the next phone. That is the power of the open sourceness of the Android platform. So I really hope this makes sense, and you can always come back and rewatch this so you can wrap your head around what's going on. But if anything, you just have to remember that for our purpose here, we're going to be focusing 99.9% on the Java API framework, because that is what allows us to actually call the APIs, call the Android classes, so that we can actually do things like creating projects and applications. Very good. I'll see you next.